There is a place on this planet darker than space, colder than any winter you felt, and more unexplored than the surface of Mars. It's not on another world, it's here, beneath the waves you've swum in, deeper than any submarine dares to go. We've mapped the entire surface of the moon. We've photographed Pluto 5 billion kilometers away. We've landed rovers on Mars and flown drones through its thin, red atmosphere. But over 80% of our own ocean floor remains completely unmapped, unseen, and unexplained. Think about that for a moment. The place most likely to still be hiding something we've never seen isn't light years away. It's directly beneath the ships crossing the ocean right now, beneath the surface you might have swum in on vacation, closer to you than almost anywhere else on Earth you haven't been. Tonight, we're going down there, into the crushing dark of the deep ocean, where sound behaves like nothing you've heard on land, where creatures glow with their own light instead of reflecting the sun's, where pressure alone could crush a human body in an instant, and where something was recorded decades ago that scientists still can't fully explain to this day. Over the next 2 hours, we'll travel from the edge of sunlight all the way down to the coldest, most crushing trenches on the planet. We'll meet creatures that look like they belong in science fiction. We'll hear sounds that shouldn't exist. And we'll ask a question that becomes more unsettling the deeper we go. How much of our own planet are we still, quite literally, in the dark about? This is Lavora Horizon, and this is the ocean's darkest secret. Let's start with a number that sounds impossible. We have better maps of the surface of Mars than we do of the ocean floor on our own planet. NASA's satellites can measure the height of a single building from orbit using radar and lasers, capturing fine detail across the entire Martian surface. But mapping our own ocean floor is a completely different challenge. Radar and light don't travel through water the way they do through the near vacuum of space. They're absorbed and scattered within just a few dozen meters. Sound waves are the only tool that works, and even sound loses accuracy the deeper it travels through miles of shifting water, temperature layers, and salinity changes. Mapping the ocean floor properly requires ships to sail slowly back and forth for months or years, pinging sonar down into the dark and waiting for the echo to bounce back, one narrow strip of seafloor at a time. It's slow, it's expensive, and only a small fraction of the ocean has ever been surveyed this way at high resolution. Even with modern satellites that can estimate rough seafloor shape by measuring tiny bumps in sea level caused by gravity, the level of detail we have for the moon, Mars, and even asteroids millions of miles away is still sharper than what we have for our own seafloor, which means the deepest 20% of our oceans are, quite literally, a bigger mystery to us than the red planet 93 million miles away. Every single year, deep sea expeditions still discover mountain ranges, underwater volcanoes, canyons deeper than the Grand Canyon, and geological features that no human has ever recorded, hidden in plain sight, just a few kilometers beneath ships that cross the ocean every single day without anyone realizing what lies below their hull. Some scientists believe we're more likely to find entirely new species living in our own oceans over the next decade than we are to find any form of life on another planet, given how many undiscovered ecosystems likely still exist in unexplored trenches and seamounts. That thought alone should change how you look at the sea the next time you're standing on a beach, staring out at what looks like an empty, calm horizon. In 1997, hydrophones thousands of miles apart in the Pacific Ocean picked up a sound so loud it was detected simultaneously across the entire ocean basin, registering on multiple listening stations separated by enormous distances. Scientists named it the Bloop, and for over a decade, no one could fully explain it. The sound didn't match any known ship engine, submarine signature, or whale call on record, despite being compared against decades of acoustic data. Some early theories were almost too strange to say out loud on the record. An unknown creature, larger than any animal ever documented, hiding somewhere in the deep ocean's most unexplored basins. The idea captured public imagination for years, inspiring documentaries, articles, and endless speculation about what could possibly produce a sound loud enough to be heard across an entire ocean. The real answer when it finally came, was almost stranger than fiction in its own way. The sound matched a massive ice quake, ice cracking and fracturing deep beneath Antarctica, transmitted for thousands of miles through the ocean's unique, deep sound channels that carry noise with remarkably little loss in energy. But here's the unsettling part. The bloop wasn't the only strange sound recorded down there, and it wasn't even the last. Hydrophone networks, originally built during the Cold War to track enemy submarines, have picked up dozens of other unexplained noises over the decades, some given nicknames like Julia, Slow Down, and Upsweep, each with their own strange acoustic signature. Many of these have since been linked to icebergs, seismic activity, or marine mammals, but a handful remain only partially understood even now, filed away in research archives without a fully confirmed source. Sound travels differently in the deep ocean than it does in air, largely because of a phenomenon called the deep sound channel, a specific depth layer where temperature and pressure combine to trap sound waves, allowing them to travel enormous distances with very little loss in volume. This means something happening on one side of an entire ocean basin can, in theory, be detected faintly on the other side. It's one of the reasons the deep sea feels less like a silent, empty frontier, and more like a vast dark room where you can hear something moving in the distance, but can't quite see what it is, no matter how hard you strain to look. Sunlight only penetrates the first 200 meters of the ocean in any meaningful way, a region scientists call the sunlight zone, or epipelagic zone. Below that lies the twilight zone, officially known as the mesopelagic zone, where light fades to almost nothing, and only the faintest blue glow filters down from above. Beyond that lies the midnight zone, the bathypelagic zone, where no natural sunlight has ever reached, not even a trace, and where the water temperature hovers just above freezing year-round. Yet, life doesn't stop here. It adapts in ways that seem almost impossible to imagine if you've only ever seen ocean life near a coastline. The anglerfish, one of the most recognizable deep-sea creatures, dangles a glowing lure directly above its own mouth, using it to attract curious prey close enough to strike in the pitch-black water. The barrel-eye fish has an almost unbelievable adaptation, a transparent, dome-shaped head that allows its tube-shaped eyes to rotate and look upward directly through its own skull, spotting the faint silhouettes of prey swimming above against the last traces of surface light. The giant squid, a creature that inspired centuries of sailor legends and stories of sea monsters, was not filmed alive in its natural deep-sea habitat until 2012, meaning humanity only confirmed what a living giant squid actually looked like in the wild within the last generation, despite the species being known from washed-up remains for centuries before that. Many deep-sea creatures have evolved bodies that are almost entirely see-through, an adaptation that helps them become nearly invisible in the dark by reflecting almost no light back toward a predator's eyes, effectively erasing their own silhouette. Others take a completely different approach and generate their own light entirely, a phenomenon called bioluminescence, which we'll explore in much greater depth later in this documentary. Still others have evolved enormous sensitive eyes to gather every last photon of available light, while some species deep enough in the midnight zone have abandoned eyesight altogether, relying instead on vibration, pressure changes, and chemical signals to sense their surroundings. What's truly remarkable is how much life exists in a place with no sunlight, immense crushing pressure, and near freezing temperatures, proof that the ocean has been quietly writing its own rules for survival long before humans ever developed the technology to look down and see it for ourselves. If you took Mount Everest and dropped it into the deepest part of the ocean, its peak would still sit over 2 kilometers below the surface, completely submerged with room to spare. That deepest point is called Challenger Deep, located within the Mariana Trench in the western Pacific Ocean, reaching nearly 11,000 meters below sea level. The pressure at that depth is over 1,000 times what we experience at sea level, roughly equivalent to the weight of 50 jumbo jets pressing down on a single person, or the entire weight of the Eiffel Tower balanced on your body. Only a small handful of crewed missions have ever reached the bottom of Challenger Deep, far fewer than the number of people who have walked on the moon, which itself is fewer than 15 individuals in history. The first crewed descent took place in 1960 using a specially designed vessel built to withstand the crushing pressure, and it would be over 50 years before anyone returned to that exact depth again, largely due to the extraordinary engineering challenges involved. Despite the crushing conditions, expeditions have found life even at the very bottom of the trench, strange amphipods that resemble small shrimp, single-celled organisms adapted to extreme pressure, and sediment samples containing traces of pollution that has somehow made its way down to the most remote, hardest-to-reach point on the entire planet. That last detail troubles many scientists more than almost anything else discovered in the trench. Even in a place this isolated, harder to reach than the surface of the moon, humanity's environmental impact has already arrived before we have, carried down slowly over decades by sinking particles and ocean currents. Researchers have also found evidence of plastic waste at the very bottom of the trench, a sobering reminder that no part of the ocean, no matter how remote, remains untouched by human activity happening thousands of meters above. The trench remains one of the least visited, least understood places on the entire planet. In terms of the number of visits and the quality of our maps, it sits closer to the surface of another world than to the beaches most of us have stood on in our own lifetime. There are more historical shipwrecks resting on the ocean floor than most people realize. Estimates suggest over 3 million shipwrecks lie scattered across the world's oceans, spanning thousands of years of human seafaring, and the vast majority have never been located or properly documented. Cold, dark, low-oxygen deep water actually preserves wood and metal far better than shallow coastal waters, where wave action, sunlight, and marine organisms break down materials far more quickly. This means some of the best preserved shipwrecks in the world are also, ironically, the hardest to reach, sitting untouched at depths that only specialized equipment can survive. When the wreck of a famous ocean liner was finally located in 1985, it had rested undisturbed for over 70 years, resting over 3.5 kilometers below the surface, deeper than most submarines of that era could safely travel, which is part of why it remained hidden for so long despite extensive earlier search efforts. Since then, deep-sea expeditions have discovered wrecks from both world wars, resting largely intact on the seafloor, ancient trading vessels carrying cargo untouched for centuries, and ships whose disappearances were treated as unsolved mysteries for generations until their wreckage was finally located decades or even centuries later, often solving mysteries that families and historians had given up on ever answering. Some wrecks have been found remarkably intact, their structures barely touched by the crushing pressure and near freezing cold that would normally destroy most materials given enough time, preserved almost like a frozen snapshot of the moment they sank. Modern technology, including remotely operated vehicles equipped with high-resolution cameras, has allowed researchers to survey wrecks without physically touching or disturbing them, preserving these underwater sites as historical records rather than treasure to be removed. Every wreck discovered raises the same quiet realization. The ocean isn't just a body of water, it's the largest, least disturbed museum on Earth, holding records of human history, tragedy, trade, and exploration that we've barely begun to properly read, catalog, or understand. Naval sonar operators have logged unexplained contacts for as long as sonar technology has existed, signals that appear on screen, move in patterns inconsistent with any known vessel, animal, or geological feature, and then vanish without a clear explanation, leaving behind nothing but a recorded blip and an open question. During the Cold War, extensive hydrophone networks built specifically to detect enemy submarines picked up far more than just military activity. They recorded whale songs never documented before, mysterious biological sounds from unidentified sources, and geological noises that took researchers years, sometimes decades, to properly identify and categorize. Some declassified reports from that era describe sonar contacts that appeared to move faster than any submarine of the period could realistically travel, an anomaly later attributed largely to unusual water temperature layers that can bend and distort sonar readings, creating false or exaggerated signals that look far more dramatic on screen than what's actually happening in the water. This effect, where different water densities and temperature gradients bend sound waves unpredictably as they travel, remains one of the most common scientific explanations offered for so-called ghost contacts detected in deep water environments. Still, not every historical sonar mystery from the past has been fully resolved to everyone's satisfaction, and militaries around the world continue to encounter unidentified acoustic signals in the deep ocean even today, decades after the technology was first developed. Marine biologists have also pointed out that many deep-sea creatures produce sounds far louder and stranger than most people would expect. And as new species continue to be discovered, some historical unexplained sonar contacts may eventually be traced back to biological sources we simply hadn't identified yet at the time. The ocean's ability to distort, carry, and disguise sound over enormous distances is part of what makes it feel so unpredictable, even to the most advanced detection systems humanity has ever built. Systems capable of tracking a whisper-quiet submarine, yet still occasionally left puzzled by something moving in the dark. In 1977, scientists exploring the deep ocean floor near the Galapagos Islands, using a submersible, discovered something that shouldn't have been possible according to the science of the time. Entire ecosystems thriving around cracks in the seafloor, in total darkness, fueled not by sunlight, but by chemicals rising directly from inside the Earth itself. These are hydrothermal vents, underwater chimney-like structures that spew mineral-rich water heated by magma beneath the ocean crust, sometimes reaching temperatures over 350 degrees Celsius, hot enough to melt lead, yet surrounded by water just above freezing only a short distance away. Instead of relying on photosynthesis, which is impossible in total darkness, the bacteria living around these vents use a process called chemosynthesis, converting chemicals like hydrogen sulfide, normally toxic to most life, into usable energy. Around these bacterial colonies, entire food chains flourish in conditions once thought completely uninhabitable. Giant tube worms that have no mouths or digestive systems at all, relying entirely on internal bacteria to produce their food. Blind shrimp equipped with heat-sensing organs instead of eyes to navigate near the scalding vent openings, and crabs specially adapted to survive in mineral-saturated, near-boiling water that would instantly kill most other ocean life. This discovery fundamentally changed how scientists think about life itself, proving conclusively that sunlight is not a strict requirement for an ecosystem to exist and thrive, a finding that reshaped decades of assumptions in biology textbooks almost overnight. It's part of why hydrothermal vents are studied closely by researchers interested in the possibility of life existing on other worlds. If life can thrive here, in conditions once thought entirely impossible to survive, fueled by chemistry rather than sunlight, it significantly raises the odds that similar biological processes could sustain life beneath the icy, sunless oceans believed to exist beneath the frozen surfaces of certain distant moons in our own solar system. Some of these vent ecosystems are so unique that individual vent fields have their own distinct combinations of species found nowhere else on the planet, effectively making each one its own isolated evolutionary experiment, hidden kilometers beneath the surface and disconnected from nearly every other ecosystem on Earth. Scientists estimate that up to 90% of deep-sea creatures produce their own light in some form, making bioluminescence not a rare or exotic trait, but the default way of life for most animals living in the deep ocean. Creatures use this glowing light for entirely different purposes, depending on the species and their particular survival strategy. Some use it to lure prey directly toward them, like the anglerfish, while others use sudden bright flashes to startle and disorient predators, buying a crucial second or two needed to escape into the darkness. Some species release glowing clouds directly into the surrounding water, functioning almost like an underwater smokescreen to confuse and disorient anything actively hunting them in that moment. Certain deep-sea shrimp have taken this even further and can shoot glowing chemical fluid directly at an attacker, essentially blinding it temporarily in the total darkness while the shrimp makes its escape unnoticed. Perhaps the most fascinating adaptation is counter-illumination, a defense mechanism used by some squid and fish where they produce a faint, carefully calibrated glow on their undersides that matches the dim light filtering down from the surface far above, effectively making their silhouette disappear entirely when viewed from directly below by a hunting predator. This light isn't produced through electricity, fire, or reflection, but through a precise chemical reaction between compounds called luciferins and enzymes called luciferases, a biological process scientists are studying closely today for potential use in medical imaging, environmental sensors, and other emerging technologies. Some species can even control the color of their light with remarkable precision, producing red, blue, or green glows depending on the exact chemical combination and the specific purpose that light serves at that moment. In the deep ocean, light itself has become a language, a weapon, a disguise, and a lure all at once. And in some of the darkest places on the planet, nearly every living thing has learned to speak it fluently, using light in ways surface-dwelling animals never needed to evolve. Beyond the trenches and the hydrothermal vents lies the abyssal plain, a vast, flat expanse of seafloor covering more than half of the Earth's total surface area, making it the single largest habitat on the entire planet, and also, somewhat surprisingly, one of the least explored and least discussed. Temperatures here hover just above freezing year-round, pressure is immense and constant, and food is genuinely scarce, drifting down slowly from the sunlit surface waters in the form of what scientists call marine snow, a continuous, gentle fall of organic particles, dead organisms, waste, and debris, sinking from hundreds or even thousands of meters above over the course of days or weeks. Life on the abyssal plain has adapted by moving slowly and needing very little energy to survive, with some organisms living for centuries due to an extremely slow metabolism suited to the cold, food-scarce, and perpetually dark environment. Below the abyssal plain, in the deepest ocean trenches on Earth, lies the Hadal Zone, named after Hades, the ancient underworld of Greek mythology, a fitting name for the deepest, most crushing region of our planet's oceans. Despite pressure that would instantly kill most surface-dwelling life, specialized fish and invertebrates have been found even here, adapted with unique proteins and cellular structures that allow their bodies to function normally under conditions that would collapse ordinary biological cells almost instantly. Researchers studying Hadal Zone organisms have found that many possess biochemical adaptations found nowhere else in the animal kingdom, offering potential insights into medicine, materials science, and our broader understanding of the absolute limits of what life can endure. The abyssal plain and Hadal Zone together make up the largest, quietest, least visited landscape on our entire planet, a slow-motion world existing just beneath some of the busiest shipping lanes on Earth, utterly unaware of the ship's cargo and human activity passing directly above it every single day of the year. Not everything found on the ocean floor is a creature or a shipwreck. Over the decades, sonar surveys and deep-sea expeditions have occasionally mapped unusual formations, including geometric-looking rock structures, unusually straight lines running across the seafloor, and formations that spark genuine debate among researchers over whether they are entirely natural or were shaped, at least in part, by ancient human activity long before recorded history. Most of these formations turn out to have straightforward natural explanations. Volcanic rock formations that cool into surprisingly regular shapes, ancient coral structures that grew in symmetrical patterns, or geological faults that create surprisingly straight lines across large stretches of seafloor. But some formations remain genuinely debated among researchers even today, particularly submerged formations found near coastlines that were actually above water thousands of years ago, before sea levels rose dramatically at the end of the last ice age. As massive glaciers melted over thousands of years, ocean levels rose by well over 100 meters in some regions, meaning ancient coastlines, cave systems, and potentially early human settlements from tens of thousands of years ago now rest quietly underwater, largely unexplored and unmapped in any real detail. This is one of the most genuinely tantalizing frontiers in ocean science today, not just alien-like creatures or crushing trenches, but the very real possibility that physical traces of early human history and migration are sitting on the seafloor right now, waiting for better technology, funding, and dedicated expeditions to properly investigate and document them before they're lost to erosion or sediment. Some researchers specifically study these submerged ancient coastlines, called underwater archaeology, a growing field that combines marine science with traditional archaeology to search for evidence of how early human populations may have lived, traveled, and settled along coastlines that no longer exist above the waterline. For most of human history, our knowledge of the deep ocean was limited almost entirely by how deep a crude vessel could safely descend and return without being crushed by pressure or running out of oxygen. That reality is changing rapidly. Modern autonomous underwater vehicles can now explore depths and durations no human crew could safely survive, mapping the seafloor at resolutions that were completely impossible just a few decades ago, and doing so without risking a single human life in the process. New sonar mapping initiatives aim to fully chart the entire seafloor of the world's oceans within the coming years, a genuinely ambitious goal that would have sounded like pure science fiction only a single generation ago, and one that international research organizations are actively working toward through coordinated global efforts. Advances in deep-sea cameras, now capable of capturing high-resolution footage in near-total darkness without disturbing sensitive light-sensitive creatures with harsh artificial lighting, are revealing behaviors, hunting strategies, and even entirely new species never documented before in scientific literature. Some research vessels now use long fiber optic cables to stream real-time video directly from the ocean floor back to the surface, meaning scientists, and in some cases members of the public watching online, can observe deep-sea life exactly as it happens, rather than waiting weeks or months for expedition footage to be collected, reviewed, and eventually published. Artificial intelligence is also beginning to play a role, helping researchers sort through massive amounts of sonar and video data far faster than human researchers could manage alone, identifying potential new species or unusual formations that might otherwise be missed in thousands of hours of raw footage. Every new tool we develop reveals not that the ocean is running out of secrets, but that we've barely started asking the right questions in the first place. For every mystery solved by a new expedition or a new piece of technology, deep-sea research tends to uncover 2 or 3 new ones in the process, a pattern that has held remarkably true since serious exploration of the deep ocean first began, and one that shows absolutely no sign of stopping anytime soon. We've reached the surface again, but the truth is, we've only scratched the edge of what actually lies beneath. The deep ocean remains the largest, least explored environment on planet Earth, closer in some very real ways to the surface of distant, alien worlds than to the beaches most of us grew up visiting on summer vacations. Every sound we can't fully explain, every creature glowing quietly in total darkness, every shipwreck resting untouched for a century or more, every strange formation still debated by researchers, is a reminder that genuine mystery doesn't require leaving the planet at all. Sometimes it's just a few kilometers straight down, closer to you right now than you might have ever realized. We've traveled from the edge of sunlight down through the twilight zone, past the bloop and the strange sounds of the deep, into the crushing trenches, alongside glowing creatures and alien-like ecosystems fueled entirely by chemistry instead of sunlight, and finally back up to the surface with more questions than we started with, which is exactly how real exploration is supposed to feel. If this documentary kept you company for the last 2 hours, consider subscribing to Lavora Horizon. New deep dives into the unexplained are released regularly, and there is still an enormous amount of the ocean and the world